So now we'll come back to the error detection, error correction and detection. So whatever mechanism sender is using, the same mechanism the receiver should use to identify whether the received information is having any errors or not. So for that sender, some mechanism should be used. The same mechanism, information about the same mechanism should be intimated to the receiver so that receiver will follow that mechanism for identifying the errors. That is what is being used in this. Now for this detecting of the errors, so number of different methods are available. One method for detecting and correction is Hamming code. So the data link layer will use error detection and correction mechanisms or only error detection mechanisms, depending on. Now we'll discuss about one particular method for error detection and correction. The advantage of error detection and correction is whatever errors are being detected at the receiver place, a receiver site. So if receiver could able to correct the errors, then the receiver need not ask for the retransmission. As a result, that much amount of traffic in the network can be reduced because unnecessary retransmissions can be avoided if the error could be able to correct at receiver side. So that is one of the biggest advantage in the networks. Okay, so if at all any error detection and correction mechanisms are available, it is suggested to use that. But the thing is, so many algorithms or many mechanisms which are able to detect and correct the errors. So all possible errors may not be correctable. So one such mechanism we'll discuss at this point, that is the Hamming code. So using this Hamming code, single error can be detected and corrected, but multiple errors probably we can detect, but we cannot correct. So using the Hamming code, one error can be detected and corrected, but number of errors cannot be corrected. How it happens, we will see that. Okay. So error checking mechanism, we can do it with the Hamming code. Right? We'll see that procedure, how we can detect the error and correct the error by using the Hamming code. We'll see in the next with one example. When we are using the Hamming code, we will be using some redundant bits. So anytime you want to detect the errors from the transmitted information, we need to take the help of some additional bits. We need to use some extra bits, additional bits, to identify whether the received information is having any errors or not. So we'll be taking the help of these additional bits. These additional bits are called redundant bits. So in every transmission, should use these redundant bits for error detection purpose and correction purpose if needed. So one such code, what we are going to coming now is Hamming code. So even in the Hamming code, where M is indicate the number of message bits, that is the actual information to be transmitted, and where R is the number of redundant bits, which we are going to add along with the message and transmit to the receiver. Then with the help of this M plus R, receiver is going to identify whether received information is having any errors or not. So I want to send a message M, but I will send M plus R, where R is the number of redundant bits I'm going to use while sending the information, so that a receiver is going to identify the received information, whether it is having any errors or not. So though I want to send the information size is M bits, but I will send M plus R bits. Okay, so I have to select the number of redundant bits. how many redundant bits I have to use for my information. So for that, we'll be using a small relation between number of redundant bits with the number of message bits. So 2 power r should be greater than or equal to m plus r plus 1, where m is the number of message bits, r is the number of redundant bits. 2 power r should be greater than or equal to m plus r plus 1. If I am using number of message bits are 1, m is equal to 1. Now the right side expression is having r plus 2. 2 power r should be greater than or equal to r plus 2. If r is equal to 1, so left side will be smaller and right side will be larger. Cannot. So if r is equal to 2, r plus 2, 2 plus 2, 4, right side, and left side 2 power 2, 4. So the expression is being satisfied. That means even if I want to send 1 bit of message, I have to use 2 bits of redundant. 2 redundant bits I have to send. Then it is easy for detecting the errors like this. Suppose if I am using number of message bits are 2. 2 plus 1, 3, r plus 3. Right side expression is r plus 3. Left side 2 power r. If r is equal to 2, left side will be 4, right side will be 5. Second, not satisfied. So what you have to do is r should be 3. If r is 3, 2 power 3 is 8, which is greater than 2 plus 3 plus 1, 6. So r can be 3 for 2 message bits. Up to 4 message bits, r can be 3. 4 message bits, m is 4, r is 3. So 4 plus 3 plus 1, 8. So 2 power 3 is 8. That's how. If I want to use 5 message bits, then I have to use 4 redundant bits. Likewise, we have to use the number of redundant bits depending on the number of message bits, number of redundant bits. So 5 to 11 message bits, I need to use 4 redundant bits. If my message bit is equal to 12 or more, then I have to go for 5 redundant bits. I have to go for 5 redundant bits. So how many message bits I can go from 12 to 26? If my message is from 12 bits to 26 bits, then I can use 5 redundant bits because 2 power 5 is 32. And 26 message bits plus 5 redundant bits, 31 plus 1, 32. So that is how we can identify the number of redundant bits based on the number of message bits.